see about the chain of responsibility design pattern, theoretical real life examples, and then principles. In the next video we will try to cover the practical implementation of chain of responsibility design pattern. So this comes under this chain of responsibility design pattern comes under behavioral design pattern. There are three categories of design patterns. One is creational, structural, and then behavioral. This comes under behavioral design pattern. Here the main motto behind the chain of responsibility design pattern is avoid coupling the sender of a request to its receiver by giving more than one receiver object a chance to handle the request. So here there are, if suppose we assume this is a client and these are some servers, instead of assigning the jobs to a particular server, if we don't assign to a particular server, that request would be solved by any servers at runtime. So for example, if suppose if you are using Amazon website, if you are trying to log into the Amazon website using username and password, and then our request would be served by any one of those Amazon servers. So the client won't aware about the server details, etc. The client fire some request, that request would be solved by any of those servers, and then chain the receiving object and pause the request along the chain until an object handles it. For example, we will take the previous example itself. If suppose if you are logging to the Amazon website, we are trying to give the username password. If suppose this receiver 1 will handles only the permission related information. For example, this receiver knows only to check whether that user name and password are valid and etc. valid only, and after doing that operation, this receiver 1 will acknowledge receiver 2 that I have validated this credentials, then you can take the further jobs like that, and the receiver 2 does some job and then it hands over the job, remaining job to receiver 3. So chain the receiving objects and pause the request along the chain until an object is handles it. It creates a chain of receiver objects for a request. We have already discussed about this point in the previous example. Each receiver contains reference to another receiver. If one receiver cannot handle the request, then it will pass to the next service. We have already covered about this point in the previous explanation. If suppose if a client is sending some request to the server, if one receiver doesn't know how to handle that request, that would be forwarded to the other receiver by using the reference. This receiver 1 will have the reference of receiver 2, this receiver 2 will have the reference of receiver 3, and then these are the two categories by which a chain of responsibility design pattern can be implemented. First category is one receiver handles the request in the chain. Second category is one or more receivers in the chain handles the request. We can explain about these categories using real life examples. So this is the one receiver example, and this is this second example to explain about one or more receivers acting at the same time. For example, we will consider a quiz competition. Lenny is the quiz competitor. Lenny is conducting the quiz competition, and Raja, Chenchu and Sudha are the quiz competitors. They are trying to attend the quiz competition. So first Lenny is asking the question to Raja. If suppose Raja doesn't know the answer for that question, Raja will transfer that question to Chenchu. Chenchu will try to answer that question. If suppose if Chenchu doesn't know the answer about that question, then he will forward that question to Sudha. Here the request has been forwarded to other receivers if the receiver has no idea to reply to that request. So this is the example where one receiver handles a request in the chain. Another example is one or more receivers handles the request at the same time. For example, if suppose Lennon is visiting an ATM machine and he is trying to withdraw 520 rupees. If suppose if he is entering 520 rupees, that 520 rupees would be handled by 3 receivers at the same time. 100 rupees receiver, 50 rupees receiver, 20 rupees receiver. So what the 100 rupees receiver will do is it will try to pick the best number of it will try to pick the number of 100 rupees notes, and then 50 rupees receivers will try to pick the number of 50 notes. 20 rupees receiver will try to pick the number of 20 rupees notes. So for 520 rupees, the 100 rupees receiver would return 4 into 100, which means 400 rupees. 50 rupees receiver would serve 2 into 50, which means 100. 20 rupees receiver would serve 1 into 20, 20 rupees. Here 3 receivers are acting at the same time. So 3 receivers are communicating with them, communicating among them to reply the client with the best response. So that's the second case where one or more receivers are handling a request in a chain. So this is the example about the chain of responsibility design pattern in real life example. If suppose if you have any other doubts, you could comment those things in the comment section. I will try to answer those whenever I see it. Now we are going to see about the interpreter design pattern, theory, principles, real life examples. In the next video, we will try to cover the interpreter design pattern Java implementation. So if suppose if you want to buy software design patterns book, you could buy the book using the product link which is the description box of this video. So let's come to this point. So interpreter design pattern. So in our real life, in our daily life, we would have been using interpreter at various points of the time. For example, if suppose if you are using Google Translator, which is one of the important and best examples for interpreter. If suppose if you give in English, if you want to convert that English language to some other language like Telugu, Tamil, that Google Translator will do for us on behalf of us. Here that Google Translator is acting as an interpreter. So it interprets some input to some other output. So this is the first point. It provides way to evaluate grammar or expression. So in our real life, Google Translator has set of grammar. So for example, for English there is a set of rules, for Tamil there is a set of rules, and for all the languages there are set of rules. Using the rules only we will try to talk with others. So similarly, if suppose if you are writing any program which contains set of rules or grammars, then we could use interpreter design pattern for that. And then useful for developing domain specific languages or notations. If suppose if you are writing a program for one specific domain, if you want to extend that to some other application without adding any other things, then you could use the interpreter design pattern. So we will try to cover this point using real life using Java implementation in the next video. And then ability to define a language grammar. If suppose if you're developing any language like Java, C++ and some other languages, then you could use the interpreter design pattern to design the language in such a manner that could be easily extended, reliable and scalable. And then Java compiler that interprets Java source code into bytecode. So here in our daily life we would have been using interpreter in Java itself, because Java code is interpreted into bytecode using compiler. This compiler will convert the Java source code to bytecode. Here the compiler is acting as an interpreter which converts the source code to bytecode, and then after converting to bytecode, that could be consumed by n number of JVM machines, so Java virtual machines. So for example, if you are trying to execute bytecode in Windows, Linux and Mac, the output should be same. If suppose if you are executing in Windows, you shouldn't get irrelevant output. All these platforms should get the same output. So that's why Java is called platform independent. Here interpreter is acting at two ends. One is at the compiler end and also one at the JVM. So here interpreter is used to convert interpreter which is in the compiler, which is used to convert Java source code to bytecode, and then interpreter which is in JVM, which is used to execute the bytecode at various platforms. So in our real life itself we are using interpreter at various points, and then defines a grammatical representation for a language and interpreter to interpret the grammar. So for example, if suppose if you are designing a big complex grammar, so in that it involves a number of rules, means then we can use interpreter design pattern to design those things. And then which is this interpreter design pattern is widely used in compilers. If suppose if you want to build any compiler, your custom made compiler, then you could use interpreter design pattern to design the compiler. Using that interpreter design pattern, you could design a compiler in such a way which can be easily extended. So that's the power of interpreter design pattern. We will try to cover this interpreter design pattern Java program in the next video. So please don't skip the next video. Thanks for watching this video. discuss about iterator design pattern theory, principles, real life examples and real time examples. In the next video, we will try to cover iterator design pattern practical implementation using Java. If you want to buy software design patterns book, you could use the product link which is at the description box of this video. You can just click on that link. You can buy the book on online itself. The book price is very cheap. So first we will try to cover the first point. Access the elements of a collection object in a sequential manner without any need to know its underlying implement representation. So we can relate this with the real life example. So for example, this is a container. So there is a container. In this container there are various packages, like there is a food package, and then there is a medicine package, and then there is a toys package, and then there is a what can we say, we can say this about glass, which means delegate materials. So here this is a container. This container is moving from Delhi to Chennai. This container is containing these packages: food package, medicine package, and then toys package, glass package. So this point states that access the elements of a collection object in a sequential manner without knowing to know underlying representation. If this container needs to be delivered to some person in Chennai, we can relate that person. This is that person. This is the person who has bought this container. Here there is an intermediate person. This is the person. This person will try to unload this container packages and he will deliver those packages to this person. This is the owner of this container, and he is the iterator. He is iterator. He will try to access each package and he will try to give that package to the owner. So first what you do is you will try to check whether the container is containing something or not. Yes, initially the container is containing food, toys, medicine and glass. So you will try to access the topmost, which means this point, sequential manner. So first he will try to access the glass. So he will try to access the glass and he will try to deliver that glass to the owner, and then he will try to check whether any other packages are available in container. Yes, food, toys, this package over, food, toys and medicine. He will try to access the next element, which is next package, which is toys, and then he will deliver the toys package to owner. So once again this iterator person will check whether the package is containing any other items or not. Now the package is containing food and medicine. He will try to access the next package called medicine, and then he delivered that medicine to owner, and then he will try to access the food and he will deliver that food package to owner, and then he will check whether the container is containing any other packages. Now the container is empty. So this iterator has done his job. So that's the point here. Access the elements of the collection object in a sequential manner without any need to know its underlying representation. This owner needs to access these packages, but you don't want to know the internal implementation, which means how to handle those packages. Now what are the ways to handle the packages so that the package won't get damaged. That would be handled by this iterator. So that's his point. And the second point is collection can be list, set, array, it can be anything. For example, suppose if you consider any programming language, you could hear this word called collections. The collection is a group of things like set, list, array and etc. So iterator plays a major role. Suppose if you know somewhat about programming language called Java, then you could have heard about the iterator in collection package. So here the iterator is a class which is used to access the elements in the collection. And then OOPS. In OOPS, iterator pattern is a design pattern in which an iterator is used to traverse a container and access the container's element. So we have already discussed about this point in using this example. And then abstract the details of traversing the collection. So here this owner don't want to know the implementation details of this package information, so that would be handled by the iterator. That's what this point is stating. Abstract the details of traversing collection. So yeah, the owner has abstracted the this iterator handles those difficulties. This owner don't want to know about those difficulties at all. So this is about the iterator design pattern theory, principles, real life examples, and real time example. In the next video, we will try to cover the iterator design pattern practical implementation using Java. Thanks for watching. Discuss about mediated design pattern theory, principles, real life examples, and real time examples. In the next video, we'll try to discuss about mediated design pattern practical implementation using Java. So first, what's a mediated design pattern? Mediated design pattern is one of the important design patterns which falls under behavioral design pattern. So basically, there are three categories of design patterns. First one is creational, another one, next one is structural, third one is behavioral. So mediated design pattern falls under behavioral design pattern. So before discussing about mediated design pattern, we will try to discuss about the real life example so that you could get the theory behind mediated design pattern in a better manner. So let's consider an airport. So this is Chennai airport. In Chennai airport, if you have so in Chennai airport, a number of flights would be landing at some time, on timely basis. For example, for every 5 minutes a flight would be landed. So similarly, a flight would be take off from that pathway for every 5 minutes. So here this is the busiest airport in India, one of these busiest airport in India. If suppose, let's consider a situation where 3 flights are trying to land at the same time. So A, B, C. So A is one plane, B is one plane, and C is one plane. If suppose these 3 planes are trying to land on a particular pathway at a particular time, if there are no intermediates between them, if these 3 planes don't communicate well, then the situation will be in a very bad manner. So if these 3 flights are trying to land on a particular pathway, then there would be many chances that the flight would be dashed together and it could be busted. So to overcome this situation, every airport has ATC. ATC means air traffic controller. So what they would do is they will try to communicate with every plane that is trying to land on a particular pathway, and they will try to communicate between multiple planes. So here, if suppose A, B, C are trying to land on a particular pathway, ATC will intimate A that A, B, C that 3 planes are trying to land on that pathway, so please try to be safe. And then ATC will guide the planes which one needs to be landed first, and then next, and then other, and then the third one. So here ATC is playing a major role. So air traffic controller is playing a major role. If suppose if A needs to communicate with C, there won't be any communication facilities at all. So if A needs to communicate with C, what A would do is A would try to communicate with the ATC, and then ATC would get the information from C, and ATC would give that information back to the A. So here ATC is playing another role. So it's acting as a mediator. Suppose if A wants to get some information from C, means A will try to intimate that information to ATC. ATC will get that information from C, and then ATC will give back that information to A. So here ATC is playing another role called mediator job. So it's trying to interconnect all the planes and trying to get the information and trying to give back that information to the required plane. So this is the real life example where mediated design pattern is playing a major role. Here ATC is a mediator. So we can consider another example. Now we are trying to consider an example where multiple objects are trying to communicate with each other. So A, B, and C. A, B, and C, and D. So these are the 4 objects that are trying to communicate with each other. If there are no intermediate means, then what? If suppose A needs to communicate with B, C, D, means there should be some connection between A to B, A to C, and A to D. And then if suppose B want to communicate with A means, then there should be some connection between B to A, B to C, and then B to D. Similarly for D. So for D, if suppose D wants to communicate with A means, there should be connection between D to A, D to B, and then D to C. So here it's a complex communication. To overcome this, the mediator design pattern, to overcome this hurdle, mediator design pattern is playing a major role. A, B, C, D. These are the four objects. If suppose A needs to communicate with the other object, instead of communicating with the other object directly, it will communicate with the mediator object. So if suppose A wants to communicate with B, C, D, it just communicate with M, and it will try to give the required information. That mediator object will do the remaining job. Similarly B, C, D. So if you look at this picture, you could see the complexity behind this scheme. If you look at this picture, you could see the simplicity behind this scheme. So if A needs to communicate with the B, C, D, it just communicates with the M, which means mediator object. So mediator object will handle those hurdles and other things behind this stuff. So now we'll go back to this slide. We'll try to discuss each point in a detailed manner using these examples. The first point is reduce the communication complexity between multiple objects. So this is the scenario where multiple objects are trying to communicate with each other. If there are no mediator objects, then the situation would be very bad. Since there is a mediator object, the communication between multiple objects becomes simple. And the second point is pattern provides a mediator object which handles all communication difficulties between objects. So we can relate that point with this example. So once again, pattern provides a mediator object which handles all the communication difficulties between the object. Suppose flight A is trying to communicate with flight C and flight B. Since they are flying in the sky, they don't have they won't get a chance to communicate with each other because of some radio frequency problems like that. Here, if A needs to communicate with C flight and B flight, it just communicates with the ATC, air traffic controller. That air traffic controller would communicate with the C flight and B flight and get the required information, and then it will give that information to A. And then mediator is the communication center for the objects. We have already discussed about this point while explaining the examples. And then when an object needs to communicate with the other object, it doesn't call the other object directly. Instead, it calls a mediator object which handles those hurdles. So this is the example. If suppose A needs to communicate with B, C, D object, it won't communicate with the subject directly. Instead, it communicates with the mediator object. Mediator object will take those difficulties and then reduce the coupling between the objects. So here it's a tightly coupled, here it's a loosely coupled. That tightly coupled means if A needs to communicate with B, C, D, A needs to have the references of the B object, C object, and D object, which is a tightly coupled, coupling example. Whereas if suppose A needs to communicate with B, C, D, it needs to have just a reference of mediator object, so which is loosely coupling. So these are the theory, principles, real life examples, and real time examples of mediator design pattern. In the next video, we will try to cover the practical implementation of mediator design pattern. So thanks for watching. We are going to discuss about null object design pattern theory, principles, real life examples, and real time examples. In the upcoming video, we will try to discuss about null object design pattern practical implementation using Java. So what is null object design pattern? So traditionally, which means if you are a programmer, you would know that you would use null check for everything. For example, if you are writing a program for adding two numbers for A plus B. So what you would do is you would first check whether A is not equal to null and then B is not equal to null. So here we are trying to check whether both values are not equal to null. Then only we will proceed to add these two numbers. So here A not equal to null and B not equal to null are null checks. So that is a traditional method. Null check for every value which has some limitations and declared for. If you have failed to put the null check, then that would cause some exceptions. For example, A equal to null, so B equal to some 5. So null plus file will throw null pointer exception. So if suppose if you want some default behavior for objects which has null for nothing, so if suppose if you want some default behavior, then we could use null object design pattern for achieving this same. So we will try to discuss an example, so where we could explain the null object design pattern in a detailed manner. So please stay tuned to this video. And then next point is null object class is a default implementation. Default implementation means whenever your program requires some default implementation for nothing and null values, then you could use null object design pattern. So last point is it would be very useful if you want some special flow for something which has nothing and null value. So we can explain that point using some real life example. So for example, these are the people from whom you get the call every day. For example, A, B, C, D and E. These are the people who always call you, and the call between you and them are very important. So you are considering them as important persons in your life. And then F, G, H, I. These are the spammers. So they will try to call and they will try to tell that you have won for 50,000 rupees. So please provide your bank details. So we will credit you some amount. So for those people, you will treat them as spammers. You need to reply them only one default message, which means I am not interested. So here F, G, H are null, which means nothing. They are nothing to you. So you need to just reply them with just one message, which is I am not interested. So here this we can consider this your, and A, B, C, D are important persons for you. So you will try to call, if these people call you, then you will try to talk with them in detailed manner, and you will try to discuss many things. If suppose if F, G, H, I people call you, then you could reply only one thing, which means I am not interested. So here I am not interested is the default message, which could be handled using null object design pattern. So we will try to cover this example practically, which means we will try to implement this using Java in the next video. So please stay tuned to this series. Now we are going to discuss about observer design pattern theory, principles, real life examples and real time examples. In the next video, we will try to cover observer design pattern practical implementation using Java. So before discussing about observer design pattern, I will try to convey some information regarding a software design patterns book. So many people ask me regarding the software design patterns book, which is the best book, and where can I buy like that. So the best book information would be provided at the description box of this video. You can click on that link for buying the book on online itself. So let's dive into the software design pattern. One of the important design patterns under software design pattern is observer design pattern. So first we will try to cover a real-time example where observer design pattern is playing a major role. So suppose if you are trying to buy a smart TV on online, so this is a smart TV. So nowadays many people are buying the electrical gadgets on online. So this is one of the gadgets that people are willing to buy. So because of huge demand, the product availability has become less. So the online shopping sites are trying to follow another strategy called flash sale. So they are trying to sell the most demanded products on flash sale. So flash sale means, so the flash sale will last only for 2 to 3 seconds. So if you are lucky, you could buy this product at that time. So the flash sale would be available on every week or on every month, on monthly or weekly basis. If suppose if 4 people are willing to buy this product, so this is one, second one, third and fourth one. These 4 people are trying to buy this product, but for the first time they have failed to buy this product because of stock unavailability. So what they are trying to do is they are trying to register with this product on that online site. So whenever this product is available, then then the notification would be sent to these people. So this subject will send the notification to the registered people. So here we can relate the smart TV as a subject and these people as observers. So these people are observing something. These people are trying to buy the product. So they have registered with this subject. Whenever the product is available, that notification will be sent to these observers. So these are the observers. We are trying to buy some product and we are trying to register with them. So here, first observer, second observer, third observer, fourth observer. The first observer doesn't know the information about the second observer. Second observer doesn't know the information about the third observer. But all the information would be available under for subject. So A, B, C, D. So these A, B, C, D are the observers. A, B, C, D. Subject would hold the observer IDs, which means A ID, B ID, C ID, D ID. Subject won't hold all the information about all the observers. So subject won't hold the observer name, observer details, observer city, observer previous purchase details, like that. Subject would hold only the observer IDs. So this is the example where observer design pattern is playing a major role in real life scenarios. We will try to relate these points with the example. So first one is behavioral design pattern. Behavioral design pattern, this observer design pattern falls under behavioral design pattern. The reason behind that is it behaves based on some state. And then second point is object or subject maintains all its dependents called observers. So here this is a subject or object which maintains all the information about not all the information, which holds information about all the observers. Here it holds only the information about the observers as observer IDs. So it holds the observer A ID, observer B ID, observer C ID and observer D ID. It won't hold the observer A personal information like name and the other stuff. It holds just the ID for communication. And then one-to-many dependency between objects. One object changes state and all its dependents are notified and updated automatically. So this is the subject. If suppose this subject is changed from unavailability to availability state, then all the observers, which means all the objects which are registered to this subject, would be notified. That is this point. One-to-many dependency between objects. One object changes state and all its dependents notified and updated automatically. And another point is subject or publisher doesn't need to know anything about the observers or listeners. So I have already talked about that point while explaining the example. Subject doesn't maintain all the information about all the observers. Like it won't maintain the observer A personal data like name, age, date of birth and other stuff. Subject would hold only the observer A ID. That's it. And then very loose coupling. Here A, B, C, D are observers. They are linked with the subject. So here one-to-many dependency. Subject one and observers are many. So it's a very loose coupling. And then limitation. So subject or publisher may send updates that don't make sense to the observers. For example, if these are the 4 observers, if A observer has already bought this product on another online site, since A has registered with this subject on another site, this site would send the notification regarding this product availability on weekly or monthly basis. Those notifications are irrelevant to this observer. So this is one of these limitations, but this limitation can be overcome by using some other methods. So we will try to cover those things in the upcoming videos. So subject may send updates that don't make sense to the observers. So thanks for watching this video. Discuss about state design pattern theory, principles, real life examples and real time examples. In the next video we will try to cover state design pattern practical implementation using Java. So first let us explain with this state design pattern using real life and real time examples. So let's consider an ATM machine. If you are trying to withdraw some amount from ATM machine, what you need to do is you need to insert your card, and then you need to enter your pin, and then you need to enter the amount that you need to withdraw, and then that machine will give back the required amount based on if all the criteria satisfies. Here we can consider two states. First state is card is not inserted into the debit into the ATM machine. Second state is card inserted into the ATM machine. Yeah, these are the two internal state. If you are in the first state, if you haven't inserted your card into the ATM machine, then you could see only the advertisement and the promo videos on ATM display screen. If you have inserted your card into ATM machine, then that ATM machine would ask you the PIN number. If you have entered your correct PIN number, then you could do these following tasks. Example, you could withdraw some amount, or you can check the balance, or you can do other stuff on that. So here these two situations are considered as an internal state: card not inserted and then card inserted. So these are the two states. Based on state, the behavior is completely changed. So for example, this is the example why the state design pattern falls under behavioral design pattern. So yeah, based on state, the behavior has been completely changed. So this is one of the real life examples, and then this is another real life example. If we are considering a human life, we are also falling under state design pattern. If this human is IT professional, so he always does some work, he always does some behavior based on time. So for example, on every day 8:30 he will travel to office. So this is one of the states. And then second state is 9:30. So 9:30 a.m. he will try to have breakfast. And then another state is 10 a.m. to 1 p.m. This is another state. So at that state he will try to work in office. So these are the three states where the human life or behavior is completely changing based on the internal state. At 8:30 he was traveling to office, at 9:30 he is trying to have breakfast, at 10 to 1 p.m. he is trying to work. So these are the examples of state design pattern. We will try to cover these points with these examples. So first point is behavioral design pattern. State design pattern falls under behavioral design pattern. The reason behind that is, based on state, the behavior is completely changing. So here card not inserted, so you can't do anything. You can just view the promo videos on ATM display machine. If you have inserted a card, and then if you have given your correct PIN number, then you could do withdraw option, and you could use withdraw, check balance, and other features also. So based on internal state, the behavior is completely changing, and then allows an object to alter its behavior when its internal state changes. So I have already discussed about this point while explaining this example. So this is about the state design pattern. So this is one of the important design patterns which falls under behavioral design pattern. We will try to cover a Java implementation for this state design pattern in the upcoming video. So please stay tuned. Thanks once again. For template design pattern, template method design pattern, theory, principles, real life examples, and real time examples. In the upcoming video, we will try to cover template method design pattern, practical implementation using Java. So let's come to this template design pattern. So before that, I will try to clear this screen so that I could explain from scratch. So it defines a sequence of steps of an algorithm. So for example, if you consider any algorithm, there could be n number of steps. You need to follow those steps in a sequential manner. So only if you follow those steps in a sequential manner, then you could you can execute the algorithm with the correct output. So here we are trying to consider an example where we could use that example for explaining the template design pattern. So let's consider an scenario. So if you want to consider a house, so you need to follow these steps. For example, first you need to construct the basement, and then what you need to do is you need to construct the pillars, and then what you need to do is you need to construct the side walls, and then what you need to do is you need to do the interior design. So these are the 4 basic steps that you need to follow for constructing an house. So it can be cement house, it can be wooden house, it can be any house, but you need to follow these steps. So let us consider the second, let us check the second point. Subclasses can override the steps, but it won't allow to alter the sequence of steps. So for example, if suppose there are two subclasses, for example, cement house is the one subclass, cement house is one subclass, and wooden house is another subclass. So if suppose if these two houses need to build some house, these two if you need to build cement house and as well as a wooden house, you need to follow the same thing. You need to follow the same sequence. First, you need to build the basement. If suppose if there is cement house means you need to build the cement basement. If suppose if the house is wooden house means you need to build the wooden basement, and then you need to fix the pillars. If suppose if it's a cement house means you need to use the cement pillars. If suppose if it's a wooden house means you need to use the wooden pillars. So here the point is, the sequence of steps remains the same, but the actual implementation may differ, but sequence needs to be followed. So this is one of the examples where template method design pattern is widely used, and another example is software development process. For example, let us consider softwares. A and B are two softwares. A software mainly focuses on military security information management. B software focuses on medical information management. So it can be any software, but it need to follow this sequence. For example, first you need to analyze the software requirements, and then what you need to do is you need to design the software. You need to design the class diagrams, you need to design this flow, and then etc. And then you need to develop, and then finally you need to test. So it can be military software, it can be medical software, it can be educational software, it can be any software. It needs to follow these steps. So these are the examples where template method design pattern are widely used in real life scenarios. So in the next video, we will try to discuss template design pattern using Java implementation by taking some use case. So thanks for watching. So please stay tuned to discuss about visitor design pattern, real life examples, real time examples, principles, and the use cases where we need to use visitor design pattern. In the next video, we will try to cover the practical implementation of visitor design pattern using Java language. So please stay tuned to this series. Before discussing about the principles, what we can do is we will try to explain this visitor design pattern using some real life example. So further, I am taking a shopping mall example. So this is a shopping mall. Let us consider this is a shopping mall. So in shopping mall, we can buy many kinds of products. For example, we can buy food products, we can buy toys, we can buy dress, we can buy food utensils. So these are the four categories of products that we can buy in shopping mall. So let us consider a scenario where a country changes the tax percentage for each category on every month. So let us consider 3 months: Jan, Feb, and March. So these are the 3 months that we are considering. So that country changes the tax percentage on each month. So for each month, for example, if that country decides 5% tax for food products for Jan month, and 10% for toys, and 15% for dress, and 10% for utensils. For February month, the tax percentage varies. So the government decides that the tax percentage for food is 10% for February month, 5% for toys, 15% for dress, and 15% for utensils. For February March month, once again it varies: 5%, 10%, 20%, and then 30%. So here for each month the tax is getting varied. So here we can consider this food, toys, dress, and utensils are elements. So we can consider these things as elements, and we can consider 3 objects: Jan, visitor; Feb, visitor; March, visitor. So here for each month the tax is getting varied. So based on element, for example, food, toys, dress, utensils are the elements. For food, the tax percentage for Jan month is 55%. So that would be handled by the visitors. So these are the three visitors who are visiting the products or elements, and they are determining or executing some algorithm. So if suppose if Jan visitor visits the food, toys, dress, utensils elements, then it determines the tax percentage for that month. And then the next visitor comes for the next month, which means February month. The February visitor is visiting food, toys, dress and utensils, and it is determining the tax percentage. And then March visitor is visiting the elements food, toys, dress and utensils, and then it is determining the tax percentage for that month. So here this visitor is playing a major role. This visitor is determining the tax percentage for the elements based on various criteria. So that's these points. It changes the execution algorithm for an element object. So these are the elements food, toys, dress, utensils. The execution algorithm varies as the visitor varies. So execution logic varies as the visitor varies. Here if Jan visitor visits food products, then it determines the tax as 5%. If February visitor visits the food product, then it determines the tax percentage as 10%. That's the second point explanation. And the third point states that element object has to accept the visitor object so that the visitor object handles the operation on the element object. So here these are the four elements. These four elements need to accept the visitor objects so that the visitor object can execute its algorithm on the elements. So this is the simplest example where the visitor design pattern is playing a major role in real life example, in real time. So we can consider another scenario where visitor design pattern is playing a major role in our real life. For example, if we are conducting three types of functions like marriage and then birthday function and then wedding anniversary. So you are inviting your friends and relatives for these three functions. So here the relatives and friends are the visitors. They will buy gifts for your function based on the function type. If suppose if the function is birthday function, then they will try to buy toys and chocolates like that. If suppose if the function is wedding anniversary, they will try to buy some jewelry or some bouquet like that. So here the visitors are determining the visitors are trying to buy gifts based on the function type. So here visitors are trying to generate the tax percentage based on month and product category. So this is the example where visitor design pattern playing a major role. We will try to cover a Java implementation of a real life use case to cover the visitor design pattern in the next video. So please stay tuned.